It's on. All right, today we are going to start by doing the exercise from the boiling water lab, the one on the very back page, which is page 6 of your handout. And we start with data. We had this data from your hypothetical study. It took them 8 minutes at one table. 2 of them it was 7. 3 of them it was 6 minutes to boil the water. 2 had 5 and 1 had 4. This is rank ordering the set of data that you have over there in the paragraph. Are you guys with me? Yes, no, maybe. On this paper, here's what we're doing. It's this one, page 6. See where it says normal curve exercise, and then it's got the grid over here just like this one. Okay, it's on this page. Do you guys have this paper? Yes. Okay, so that's what we're doing. And what I've done is I've taken the first through 6 periods, I've taken all of their results, and I've just rank ordered them right over here beside the grid, so you guys can do that. I then load them in the grid. X is your raw score. So we had a 8, we had 1 of them, so that's the F column, which is the frequency. We had 2 7s, 3 6s, 2 5s, and 1 4. Okay? So that's all we did. Please pay attention. If you don't, you're not going to get this. And it's not going away. We're going to keep doing this. All right, this is the F column. Columns go up and down, rows go across. At the bottom of the frequency column is this fancy E, which is a Greek symbol, and that stands for sum of X. So what are you going to do to this column if it says sum of at the bottom of it? Add them all up. That's right. So if I add them up, 2 and 1's 3, 3 more is 6, 3 more is 9. I put a 9 right here. Now, if you have 2 things next to each other in math, what do you do with them? What do? You multiply them, right? So I'm just taking the F column, this one, and I'm multiplying it by the X column. So 8 times 1 would be what? 8. 7 times 2 is 14. 6 and 3 is 18. 5 and 2 is 10. 4 times 1 is 4. I now have this funny looking E again with F of X. What do you think I do there? Add them up. So if I take my handy dandy, and I highly recommend the Texas Instruments TI-30XA calculator for about $8, and put that in there and add it up, I am going to get 54. And I put that down here because that's what it says to do. Okay? We good to there? From this point, the next column says X minus X bar. Do you remember what X bar is? X bar is the mean. That is right. We need to calculate the mean because we don't know it yet. Here is the calculation for it. Sum of F of X, that's this number, over N. The sum of F, which is this one, N is equal to the sum of F. This not F times X. So this is 9. We put 9 over here in the N. Come on, marker. Be nice. So 54 divided by 9 will equal 6. And we carry to the third decimal. Because in the next one we're going to get into decimals, but I didn't want to do that right now. So the mean is 6. You guys good to there? Not too bad so far? All right. What's the median? Do you remember? We've talked about the median before. What is it, bud? The middle of what's special about the set. The set of numbers. You have to do something with them to get to the middle. It's all right. You rank order them. That's what this is. Rank order means from greatest to least or least to greatest. So I rank ordered our data over here, and then there's 9 of them. There's 9 numbers, so the 5th one is going to be the middle. 1, 2, 3, 4, 5 from either end. 1, 2, 3, 4, 5. So the median is also 6. Do you remember what the mode is? What is it?
The number that repeats the most.
That's right. The most frequently occurring number or measurement. In this case, it's going to be whatever is the largest number in the frequency column. In our case, it's 3. 3 is beside 6, so it's 6 also. You can also have more than one mode. We can now fill the grid out. X minus X bar. X is 8. The mean, or X bar, is 6. So 8 minus 6 is what? 2. Yep. 7 minus 6 is 1. 6 minus 6 is 0. 5 minus 6 is -1. We use the negatives here. And 4 minus 6 is -2. We got that column done. What does the next column tell us to do? This column right here. That's the next column. What does it tell us to do with the numbers? Look, guys, all we're doing is moving this over here, and we're squaring it, right? So we're going to take this number, and we're going to square it on each one of the rows. What's 2 squared? 4. What's 1 squared? 1, right? 0 squared is 0. What's -1 squared? It's +1, isn't it? So this is also 1, which is absolute value. Remember in middle school your teachers taught you absolute value and you thought, I'd never use that, and we're using it. -2 squared is 4. Is everybody good to hear? If you just follow along what it tells you to do at the top of a column, this is how spreadsheets work. If you get into a position where you're doing spreadsheets, this is all it is. You put a function and then all the columns in there. Most businesses use them. All right, what does this column tell us to do? All we did is we took this and put it in that column, didn't we? And then multiply it by what? The F column. So 4 times the 1 is 4. It goes over here. 1 times the 2 is 2. 0 times anything is 0. 1 times the 2 is again 2. And 4 times the 1 is 4. You guys good to there? Nothing too fancy yet. We then add this up. There's 6. There's 6. So what's this going to be, this sum of down here? 12, right? When you add the whole thing up, it's going to be 12. Now, we need to calculate or find this, the cherry bomb, some kids say, the standard deviation. To do that, I have to get the variance. This number is this one right here. All we're doing is dividing that by n minus 1. So we bring this 12 right down here. We divide it by n minus 1. 9 minus 1 is 8. And then 12 divided by 8 is 1.500. Got that number? Standard deviation is the square root of the variance. So that's why the big text calculator is nice. Many of them have it. 1.500, and you press the square root button, you're going to get this number. 1.22, and it's going to be 4 blah blah blah. We round to the third, it's 2.5. 1.225. Okay? Now, we can fill in this grid. This is the normal curve grid. Right in the very middle is the mean. Our mean is 6.00. I'm going to get my cheater sheet over here so you don't have to sit and watch me punch numbers all day. To get to this point right here, this is one standard deviation above the mean. I have to add a standard deviation. The standard deviation is this number right here, 1.225. Let's put it up here. 1.225. Okay. When I add 1 to it, I get 7.225. To get 2 standard deviations above, I have to add another one. When I add another one, I get 8.450. And then when I add one more, I take this number, add another one to it. It is 9.675. And these are above the mean. Okay? How would I get the ones below the mean? Sir? Okay. Do you know what the standard deviation is? Do you know what that means? Okay, you don't know where this number came from? What you use it for? You use it to build this scale. Because what happens is when you take a set of data, you can put it on this scale and you can predict or say how much is below, what percentage is below that number, what one is above that number, and that comes into play in a lot of scientific studies. You can predict how many people will spend $10 on a meal. What's the average price somebody will spend on a meal? You can run all this through here and it will tell you. So that's what it's for. Things like that. Okay? All we're doing is we're massaging numbers. We're taking a set of numbers and putting them on this graph. Okay? Now, these numbers are, which ones? These? Okay. You know what the mean is, right? 6. You know where that number comes from? Okay. And then this standard deviation means to get one of these deviations above the mean, I have to add this number to it. So 6 plus 1.225 is 7.225. To get 2 standard deviations above the mean, I have to add another of this number, 1.225, to this number. That's where the 8.450 comes from. And then I do it a third time and we don't go past 3. So 8.450, I add this 1.225 again and I get 9.675. So that's where those numbers come from. Now remember, that's above the mean. If I go below the mean, what do I have to do to the mean to start going below? I have to subtract that number from it. So I go 6 minus 1.225, and I get 4.775. And all that is 6 minus this number. How would I get to the second one? I got to subtract it again. 3.550. And to the third one, just do it one more time. 2.325. Okay? And that fills out the normal curve grid. We now have what's called a z-score. The z-score tells you where that particular score is on this scale. Okay? You do that by this number. This number is this column. The reason you use this column is because it puts the negatives back into play. And half of these z-scores are going to be negative. So this number, which is 2 divided by, what's that symbol right there? The cherry bomb, which is the standard deviation. It tells you how far away it is, so you have to divide it by this number. 2 divided by 1.225 will give you positive 1.633. 1 divided by this number, 1.225, will give you positive 0.816 when you put it in the calculator. 0 divided by anything is what? 0. That makes sense because 6 is the mean. Mean is in the middle of the scale, and the middle of the scale is 0. It tips right here, it balances. Going the other way, negative 1 divided by 1.225 is negative 0.816. And then negative 2 divided by it is negative 1.633. And you're done. That's the grid. Now we can ask some questions about that. Here's the first question. What percent of that graph is below this line right here? The middle or the mean? How much of it is on that side of it? Yes, sir.
All of it?
All of it? Is this on that side of it? See your line right here? This is like a teeter-totter right in the middle. There's just as much on that side of this line as there is on this side of the line. The z-score for this would be 0. You guys hanging tough? It would be 50. 50% or half of that curve is below. So if half of it's below, how much is above? Engage, guys, engage. You're like Top Gun, you got to engage.
I have no idea what's going on.
If half of it's below, how much would be above? If there's 100% under this line here that makes that curve. 50, just like it. Okay? So that's what we need to do. We need to be able to crunch numbers, and all you do is you follow directions. In college, they told us it was cookbooking. You just cookbook the numbers, and you get them to fall on this scale. All right? Here's what I want you to do. Your data that you got yesterday from boiling the water, for each one of the tables, I would like you to put it in this grid. And it's on the board for you video people. But you didn't do the thing, so we will get a picture of that in a little bit. The other thing I want you to do is, on the piece of paper that I gave you today, the practice sheet, this is new data. I want you to try to put that data in this grid. See if you can work that. And guys, it's important. I wouldn't do this to you unless I thought it was important. But every student that I teach, I want them to try to get this. Okay? All right, that's the day. Do that. There is a quiz, Unit 2, Lesson 6. We need to get that done, and we need to get this practice lesson done. All right, that's it.